Okay, so we will be starting the series with DP. As we all know, DP is nothing but dynamic programming. And to be honest, it is one of the most hyped up topic in DSA. Hyped up, not tough, only hyped up. Okay. First of all, I want to give some credit to the person whom I studied DSA from. Like I studied DSA from Vivek Gupta YouTube channel. Uh, you maybe know him. You may know him. Okay, so the basic thing about dynamic programming is recursion, backtracking, nothing else. This is the base. And what makes the difference between this and dynamic programming? It is just that we create an array or a vector which stores the value which get repeated multiple times, so we just store it in a vector, and then it becomes a dynamic programming problem and not a backtracking problem or recursion problem. So it is not a very unique or special thing that we must think. Okay, so the way we are going to solve the problems, like the way we are going to solve the recursion or backtracking problem, is LCCM. What does it mean? Level, choice, check, and move. Level, at which position I am. Choice, what are the choices I currently have to move. Like if I can move with taking a thing, then it is one choice, and if I can move without taking the thing, it is another choice. So based upon the question, we decide the choice. Check, that if the current move or the next move is valid or not. Like I can do the move or not. And move, if check possible, and if everything is possible, then simply move. Yeah, or go ahead. Do the recursion. Okay. So this is never choice, check, or move. Check we do for current solution, that our current solution is partial, because until we go to the last it is partial. Okay, so we do partial check. So level, choice, check, move. Confirm. Now let's move directly to one of the problem. What does the problem state? That one of the most famous problem is stair problem. A person there standing on the ground, he has two choices. Either he can move one step, or he can move two steps. Okay, he has two moves. Or let's make it more difficult by adding, he can move even three steps. So level, what will be the level? At which step currently I am. So let's first do these four things, then we can directly make the code. Okay, level, current, step, choice, one step, two step, three step. check. Okay, so now these were obvious. Now what will be the check? If current step less than equal to n, means total step. This is n. If current step is less than n, move n plus or fx plus 1, 2, comma 3. Okay, move. These are the four things that we need to think. And we thought now the only thing remaining is the code. Okay, fx better we write here level. Level plus this. Okay, so now the only thing remaining is code. Okay, so now let's solve this question. Uh, in the problem we had taken 1, 2 or 3 steps. Here we have only 1 or 2 steps. Let's solve and see if we are correct or not. So we have been given simply int n. So first of all, let's make a recursion function. So what we will be returning int rec int level. At which level we are currently at and at which level we have to go. First of all, pruning check level greater than n return 0. Now base case if level equals to n, return 1. So something we have to know, something there are some things we have to know, like in pruning case mostly we will be having return 0 and in base case mostly we will be having return 1. Mostly, not always, mostly. Okay, like these are some easy problems. So and also what does this mean? This here pruning and base case. Pruning, that what will happen if we exceed the limit, then what will happen? And base case will be if we are exactly at our limit point, like we have to go at nth step and we are currently at nth step, then what we going to return. And pruning check is if we are far from nth step, then what we are going to. Okay, now what we will be having cache check. We will see it later what it is. Cache check. Now let's leave it for now. Then compute or transition. Okay, like what we said, move, that move. So rec level plus 1 rec level. Simply I'm going to return level plus 1 plus rec level plus 2. Okay, so what I mean here, like let's again go to our whiteboard and see choice. We have 1, 2 or 3. So first f x plus 1 fx plus 2 fx plus 3. These are the three steps that we can do. Same way dot here. And why we said return? Because whatever going to be this, we are going to return this. Okay. So I don't think any difficulty should come at this point. Like we could also have done this, that what we can do, int x equals to rec level plus 1 into y equals to rec level plus 2 return x plus y. We can also do this, or we can do this also. Simple. In which way you are comfortable. Everything done. We have simply here I am going to write save and return. We are not saving anything, we are only returning. Okay, so let me show you what the problem associated with this. The answer would be perfect. Like if I show you return rec 0, and let's run the code. Identified and okay, and n. Now what's the problem? Okay, I had written n, so I have to write n everywhere. See, everything is perfectly fine, but this will give me a wrong answer. You want me to submit it, then I can, but it will give a wrong, not wrong, but TLE, time limit exceeded error. And see, you got a time limit exceeded error. Now how to solve this time limit exceeded error? For this only we have to write a vector int dp. Yes, check. Like what is the limit? I am going to 45. Okay, so I will be writing here 50 comma minus 1. That is fill every value with minus 1. If dp level not equals to minus 1, then I will be simply returning return dp level. Okay, and now what I said, we will have to save and return this dp level equals to x plus y. Another way to do this is simply return dp level equals to, if we do this, we can simply skip these two steps. Okay, so now if I will simply use test case and I done this, what now? So I made an error. Let's see what error I made. Like what I have written here, vector this, but we can't write this. The way to write the DP code is always using memset. And for memset, simply we will create an array which has maximum size of n. N will be the maximum size, or the the size or dimension of the array will be such that every value that is possible can get stored. Every value which the level passes through gets stored in this array. So now we will fill all the values using memset. And how we do this? Memset dp -1 and size of d. Simple. Just remember this single code and it will resolve all your problems. See, every case submitted. That's even if we submit the code, it will be completely correct. Beats 100%. This was the code, and this is how we write. This is the way to write. Like I can also write here, memset is compulsory, and create array like, okay, simply. Now let's move to our other problem. So we should not forget that we were not directly studying DP, but we were studying the backtracking. Like this, all methods are for backtracking, and as backtracking and DP is just same, it just that DP has an extra array. That's why it is DP. So let's practice some more backtracking problem. And I will during this I will also tell you why the problem is backtracking and not DP. Like what is the difference between backtracking and DP? A little bit a border there between backtracking and DP, and we will see what kind of border it is. So now let's study one of the tough backtracking problem, which is called n queens problem. Okay, n queens problem. So what does this n queens problem state? So this problem states that so place n queens on the board such that no two capital N queens attack each other. Like, have you understood what does this mean? On an n cross n chessboard, on n cross n chessboard, like here I have 8 cross 8, the original chessboard. So I have to place 8 queens on this. So how I am going to do this? First, if I place one here, place second here, third here, fourth here, then and next if I fifth here, sixth here, seventh here, and eighth here. Got my all 8 queens such that no two queens attack each other. Is there possibility of any more queens? Obviously no. And how we can say obviously no? Because in any row or column you always get one queen there which will attack. Okay, So this is how we place our 8 queens. So what will be the pattern? As we know that for every number we can find like this. Let's see for a 2 cross 2 also. Like this is one chessboard. This is 2 cross 2. Can I place 2 queen here? Obviously not. Like if I place 1, I cannot place the other queen here. So I cannot place the n queens. Okay, understood? So now let's move to the problem. This is a tough problem because in the first guess, I think no one can predict that this is solved by backtracking. Okay, so this is one of the problems which you need to remember for further. Okay, like these questions can be asked directly because these are some original problems or one of the best problems out there. Okay, of backtracking. We have to learn that this problem is of backtracking and like it cannot be solved by any other method. This is only a backtracking problem. And why backtracking, not DP? We will discuss it later. But first, we need to remember that this is a backtracking problem. So we will think in that direction only. Okay. So in this problem, we have to return the position of each coin. We have to return the position of each coin. Like here it is q dot 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 dot. Okay, then then q and go on. Okay, it is like this only. We have to return the position of each coin. So first of all, let's try to frame the problem using our method, NCCM method. So level, current position, choice. What is the choice? Choice will be the column to place. And why column, not row? Because if you see that we are going like this. So let me show you again. Like first of all here, then in this column, then in this column, then in this column, then in this column. We can also do row. It is nothing like that. We only do columns. We can also do the row. But here I am considering column. Okay, I am considering column. Column to move. We can, because first of all I need to move in one direction, so I am choosing that direction to be columns. Row two. Okay, I don't. Then check is simple. If it is possible to There's the queen at that position. Okay, and then move. Go to next one. Okay, so these are the 4 steps, and this is how we frame any backtracking problem using LCCM. If we see, our all codes are like of the form. Which form? Like int recursion, int level, base case, pruning, base case, then computing, and it goes like for all choices, move choice, and no, there is one more step involved, like first check if check choices choice is valid, move choice. Okay, so it is like this. So what we are going to do here, that first of all we will create a check function. Before going anywhere, we will create a check function. If it is possible to move. Here we can't simply write a line and say if it is possible or not. We have to write a function for this. Okay, so we will write a check function, and how the check function will work is going to amaze you, because instead of saying, because I think I should just show you how it gonna work. So bool check int row int column, in which row and in which column currently I am at, and bool because it will tell true or false that it is possible to go in that current position or not. Okay, so let me first write the code for int I equals to 0, I less than row, I plus plus. Okay, before this I am also going to write our dp function. Here we are not writing dp function, instead we are writing a function, dp function, why I am saying function dp array. We are not going to write dp array here, instead we will write int queen I. And what does this going to denote? First of all, I am writing here the complete size, that is the maximum limit. Let's consider the maximum limit of n given in question is 20. Let's see what it is given. Okay, so it is given only 9, not even 20. For Solving the problem, I took it 20. Okay, it is not a problem. Big deal. Okay, so the iterator will denote row and queen will denote column. Okay, so this is what currently is. So in how this is checking, because let me show you. Let's consider I am at this row. It is going to verify for all row before this. Like it will go here, it will go here, it will go here, and see that the current column is possible or not, the next column is possible or not, the next column is possible or not. And it will check for the same number of rows and the same number of column obviously. Like if I am in the second row, so it will simply check till the second column and say no, it is not possible. So our column will get increased. Then it will check for the next column. Like we during recursion we are increasing column wise, and in the loop we are increasing row wise. So for row wise we will check, and our recursion will take care for moving further. Recursion and here loop. Okay, this is how it will work. P row, or you can write C row, that is current row. And P column equals to queen I it will denote in which column queen is present. These two will denote this. Now we will check conditions, like if our current position collides with row, column, or diagonal. We know why, because queen can attack like this. Okay, queen can attack like this, so we need to get not included in any of these. So for this, what our condition will be, if p row equals row, or not p row but column, that is if queens are in same column, then it is a problem. We can also write p rho equals rho. Or now diagonal case. Abs p rho minus rho equals abs p con minus con. Now what does this mean? That whenever diagonal thing, then it will always make 45 degree. Or here I can say 90 degree, 45. So these two lines will be equal. Okay. So as these two lines will be equal, so absolute P rho minus rho equals absolute P rho. In this case, we will return simply 0. So this is our check function. Now when we wrote the check function, I think we should move ahead with our recursion function. So for the recursion function, how we are going to proceed in this is that first, one thing is left in the last function is that if this happens, then we will return 0, and if this does not happen, then we will return, like I can also write here and then write return 1. You cannot see this because it has gone out of the range, but I have return 1 after the for loop. Okay, so everything's fine with this. Now let's create our recursion function. So int rec. First of all, what I am going to put in the recursion function will be int row, int int column, or no, I will solve it the way I thought it. How we thought it? First of all, let's see. Level, choice, check and move. Level will be our current position, okay? And we are positioning according to the column, okay? So we don't need row. I will only write int level, okay? Level denoting column here. We are moving column wise and we are also checking row wise that every row should be correct. Okay. We are moving column wise and we are checking row wise also. We can move in only one direction. It is not that we can move in both direction rows and according to column. We will only move in one direction. Okay. And have I explained you how we thought? Maybe I did explain you how we thought this one. This maybe if possible I can highlight this. Yes, highlighted is present. Oh, not green. This is already green. Take something and orange. Okay. Yes. This is a very unique way to check if the current row column come with in diagonal to the P row and P column. Okay. A very unique way to check it, and we should remember the way how we did. Okay. So now let's move to the recursion function. Level denoting column here I already wrote. So first of all, maybe so now our base case will be you can write pruning before pruning will be easy. I am writing directly base case. If level equals n, that is we reach to the end of the board, then we will simply return 1 because I have already said in most cases, in base case, we are always going to return 1 in most cases. Int answer will be 0. Okay, so int answer will be 0. Now we will simply compute transition, or we can say we can loop over choices. See, later I am going to tell you form wise, like form 1 of DP, form 2 of DP, form 3 of DP, form 4 of DP, and form 5 of DP. And in the form 1, we will study that the form 1 is based upon take or not take. Okay, form 1 is based upon take or not take. And as it is based upon take or not take, so we generally only have two transition. Generally, sometimes we will have to loop over choices. Like we have been given many choices and we have to loop over that. Okay. So like in this question, we will understand how and what does loop over choices means. So for row equals to 0, row less than n, row less plus, and yes, row, because we took here column, so we will loop over row. Okay, for all rows such that we can check if we are currently at this position. This is some xth row, yth column. So we will loop over all the rows by this method. Okay, xth, yth. Okay, so as we have to loop over all the, so if check row comma level, as level is column here, if it is possible, because it will return 1, that is true or false. If it is possible that we can place it here, then queen level will be our row. Actually, I think I made a mistake here. Here, level denoting row. Okay, and we will not go with this method. We can go, but we have to change the check and all other stuffs also. Okay, so for the sake of simplicity, I will write column here. We are iterating over all the column. It will be not difficult once I write the complete code here. Level column. Okay, queen level will be column, answer plus equals. Okay, so now answer will be recursion level, that is next row, move to the next row, and queen level will be -1. This is the backtracking step. Backtracking step. This will be the backtracking step. Okay. So now for each check and this thing, we will return answer at last and end the for loop. This is the backtracking step that I was talking about, and it is very much important. So this is the complete code of and queens. So this is what we have done. Like I have just changed the row and column thing and replaced because the label here denoting the row. Okay. For now, just understand it. I will tell you why and all this. So now this is the code, and now let's talk about why this is backtracking and not backtracking and not DP. Why? So this is a backtracking code and not a DP code because if we go to the pattern first, yes, we can see no 2 points overlap. That is, no two labels ever going to overlap. Like if we increase it to here, then I'm again not going to come at this point because it is not possible to have two coins on the same piece or the same position. Okay, so if I am not going to come back to this point again, then there is no use of storing that position. We can do the DP thing, but it will not going to reduce our time complexity because if we are not going to come at this position, then we will just keep on storing and never going to use it. Okay, this is why we use this backtracking and not DP. We can do, but we don't because there is no use of it. Okay, simply there is no use of it. Now let's try to write the same code in lead code. Okay, so let's write the code. First of all, I am going to declare a queens array which will going to store the which will going to store the columns. Okay, so in queens and the size. What is the size here? Maximum size 9. So let's declare an array of 10 size. 10. It doesn't matter. Okay. And also let's do this. Set queens -1. Okay. Now we check row into column. Now int p row equals to first of all a for loop. Mm, Where is the row? Okay, and I plus plus int p row equals I int p all equals wins I. Now let's check if the current position of row and column collides with any previous row and columns. So if p row equals to row, p col equals col, though we know that row never going to collide, okay? Because I never going to become row. If I never going to become row, then this is waste. So we can simply delete it. We delete this also, and then yes, now here apps equal minus call equals apps p row minus row. If it is like this, then we'll simply return 0 or false, and if it completes all the for loop, then we can simply return 1. Okay, so now let's call our recursion function int rec and int level int n, because we need to basically define, okay, like we need this n, so I am going to store, I am not globally declaring this n, so you know obviously. So now let's write the code. First of all, cloning case if level greater than n, return 0. It is not going to happen. Then base case if level equals n, return 1. Then there is no cache check because it is backtracking code and not DP. Okay, so let's further move to computes plus transition. Now for int I equals to 0, I less than I plus plus. What does I denote here? I denotes column. Okay, because our level denotes row and I denotes column, and we are checking for each row in every column. Okay, so if check level comma I, if it is possible, then what we are going to store in this queen? We did not find anything, we just used it. Now we are going to fill that queen. Okay, queen level equals simply I, because it is going to show the column. Okay, the code is very easy to understand, it is not difficult to understand. Okay, so our answer must have this. int answer equals to 0, answer the sequence, and now when we used queens, not queen, okay? Queens level equals -1, reverting back to the original. This is what backtracking means, and we will simply return our answer. And here simply we will return rec. So yes, this is the code, but not of n queens. It is of n queens 2. Like there are two n queens problem in the neat code. So I'm going to copy this code till here. And then this part here. And let's see the errors we get. Okay. Yeah. That is not obviously. Sometimes I literally do a weird kind of thing. Let's see. Accepted. Okay. So this is our code. Nothing wrong in it. Let's see to submit. After submitting, if it gets submitted. And yes, it is accepted. Beat 68%, 68.94% of the answers and all. So I guess we do not have any problem in this code. It is very easy code. Okay, so this is n queens 2. What does n queens mean? So in n queens, it is just asking the position. Like what we can do here is globally declare a, wait, let me show you. Vector int v wait, cut. Just wait a second. Comma vector v. Okay, and here also I am going to declare this type of array and comma vector dash. Okay, nothing else. So the way to declare a size of a 2D vector is like this, and comma vector int and comma 0. Okay, so this is how we declare it, and just write here simply 0 comma n comma v. Now I need to change it everywhere, comma v. Also, simply we're going to write v so not actually this is not a this is a string. This is string. I'm going to fill it with dot because that's what said here. So dot here also not int but string. Now vector level I equals q. Now we can simply return call the function and it will like okay and also and v okay, so it does not become a copy. We call the function and we simply return v. Let's see if we get any error. And yes, we get error. Can it get resolved by this? Okay. Got. So our output is like this. Okay, so our output is like this. Q, but we want it like this, okay? So what is the error here? I guess which type of error is this? Like we have 4 into 4, but here it demands okay. It demands this in 1. Okay, I understood almost. Like it want 2 rows and n columns. Okay, this okay now? No, obviously. I understood. Let me resolve this issue first. And so what I did in this problem, let's discuss that. I added 2 strings. One which I added 2 things. One which is vector of a string, which is going to store the final answer, and one which is vector of a string that is going to store the temporary answer. Uh, like we need to give all the possible positions, not one. Like if I got this position, then I have also have to get to this position. So I need to revert back it again and again. So I first of all pushed one answer in this. Then vector of string will store other answers. One answer will be given by this, second answer will also be given by this, but before giving to this, we need to push back this to our final answer. Okay. So I use these two in the argument. Then let me show you. When level equals to n, that is our row has reached to the last row. We have reached to the last row, which is this row. When we have reached this row, then we can simply push back our answer in the vector of string. That is final. And before that, let me show you. Here, we simply wrote vs. First of all, we need to know that the vs array consists of only dots, nothing else. It is an n-sized vector which consists n-sized strings. And this is what we wanted. Like if we see the test result, let me show you. Yes, you can see this is n-sized string and times. That's why it is n into n. And we got two positions, that is two answers for that. So our vector of string is also n-sized vector which consists n-sized strings. Now we only need to change position where check never gets satisfied, never and I. So we'll simply change the position. What does this denote? This denote that, let me say, that at this level and at this level or row and at this position I. What does I going to denote? At this position and at this column, simply Q is pushed back. Okay, that's all. Easy question it. Okay, just some implementation issue, and this is an implementation problem to be more precise. Okay, so we have studied this backtracking problem and quiz. Now let's move ahead. So I have written a new problem here. The problem states that, for example, I made a competitive programming course. Okay, so in the competitive programming course, let's say the course is of 3 hours. The course lectures are of the form 3 hours, 5 hours, 7 hours, and the skill you are going to get from those lectures are two. Let's say we somehow measure the skill. So you are going to get 2 skill, 6 skill, and 8 skill respectively. That is, if you do the 3 hour course, you are going to get the 2 skill. If you are going to do the 5 hour course, you are going to get 6 skill. If you are going to do 8 hour, 7 hour course, you are going to get 8 skill. It is not such that it is not in increasing order. Like, don't think it is going increasing, then also skill will increase. It may happen that 2 and you get 9 skill. Okay, it can also be like that. Okay, and it is given that you can only take K lectures. Out of all the lectures of CP I made, you can only take K lectures. After that, you need premium subscription or anything, but you can only take K lectures. Okay, and T time limit is given that you have only T time. That is, let's suppose you have only 20 hours. You can take only 20 hours course. Okay, these are the restriction you have been given. Now you have to maximize the skill in these constraints, that is K lectures and T time limits. Okay, so this is our problem, and the solution goes like, before diving into the solution, let's discuss the approach part first. Uh, I have still not taught you the forms like form 1, form 2 and all. So before telling you what the form is, let's form of DP. There are 5 forms of DP, I told you already. So before diving into the form, let's suppose we know that study, we need to solve this question in with respect to recursion or backtracking. Let's suppose we know, and how we know, we will know after studying the forms. Okay, so and also you can think that we go into recursion such that what is recursion? Recursion is just like loop. You can always do recursion instead of loops. But why we don't do recursion always? Because loops are bit easy to understand and recursion is basically a little complex. So here we know that we need a loop to iterate through all these things. So we can do it with recursion. And we will do with recursion because let's suppose I go from this to this, then go from this to this, and our answer goes wrong. So there must be a step such that we can directly go from this to this. Okay, and solving it with for loop or while loop may be difficult with this. That's why we will go with recursion. Okay. Now we know why we will think in the direction of recursion. And whenever we think in the direction of recursion, how we solve it? LCCM. We know the method LCCM. How it goes? Level, choice, check, and move. Okay. Level. Current lecture I am at. Current lecture. Choice. If number of lec less than equals to k and 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 number of hours less than equals to time. Okay, this is check part, not choice part. Let me. This is check part. Obviously, this is check part, not choice part. Choice. Okay, so what are the choices we have? We can take the current lecture or not take the current lecture. Okay, there are only two choices, take or not take. That is, we can either study from this lecture or not study from this lecture. So the two options are take, not take. Okay, now move. If it is sufficient, then we'll simply take it or not take it. Easy. So this is the approach. Now let's move to the coding part. So let me add a page. Okay. So we will study two methods for this. For this problem, we are going to study two methods. One is without leaping. And one is with DP. Okay. So first of all, obviously, we are going to study without the DP. So let me put it aside and let's discuss the DP part first. So I think we should directly move to the code and I will discuss the approach in that after code. Code. So in the code part, first of all, take input of time and skill arrays and maximum time possible and maximum lectures possible. Let's suppose we took it all. Then, first of all, let's write the function in the same way we done, right? Till now. Okay. So, int recursion and int level, because we always write code like that. Now let's move. Level is current item we are taking or current lecture we are taking here. First of all, pruning case. So what can be the pruning case? If current lecture, or I should say level, greater than n, that is I have exceeded the size of the array simply. Maybe I should write something here, n size of t slash s array. Okay. If level greater than n, then simply we are going to return 0. Then base case, if level equals to m, then also we are going to return 0, because returning anything will lead to the increase in value. So we can't return 1. First of all, what is the recursion function going to return? We will study that what is it is going to return. What we need. First of all, let's see what we need. We need to maximize the scale. So what our recursion function is going to return? The maximum scale. Okay. It is going to return scales. So now we know what the recursion function is going to return. Now let's compute over transition, whatever we can say. Okay. Loop over choices. We have only two choices, either take or not take. So we are going to loop over the choices. Loop over choices, take or not take. So first of all, if we take, then we have two choices, that is take or not. So what we can do is just store the maximum of 2. So what I mean by this is, let's suppose simply we write here int answer equals to ref level plus 1. This is our first choice. Then we do not take. Okay. Not take. And second choice, if we can take. So before taking, we must check that it is valid or not. If check level not equals to -1, answer equals max answer comma s level plus recursion level plus 1. This is after taking. So what does this S level denotes? This S level denotes the skill of current level. So this is the code. Now we must write the check function. So I am going to return answer here and just close the bracket. Okay. So this is the whole code. Now it is not yet complete because we still does not know how to write the check function. So what we need to check that we can take the current scale based upon the time and amount or not. Okay. So we write the check function here. Bool check in level. Okay. So this is the code. This is the function. Now what we need to write? First of all, time taken. Let's suppose in the beginning time taken is 0. Suppose not, it is 0. And item taken, item denotes lecture here. Okay, so item taken equals to 0. Now how we are going to access that how much we have taken? So for that reason, I think we need to make an array. So int taken m. Okay, so as we can take all, so we made the array of size n. Okay, and if it passes the check, then taken level equals to 1. Okay, and as we are checking for every option, then it may be possible that we revert back to whatever we took. So we need the backtracking code also. Backtracking step, not code. Level equals 0. We initiated this with 0 first. Okay. This is the whole code. Not whole code because still we are left with bullshit. So now we will simply iterate over this taken array and let's see if we get or not. So for int I equals 0, I less than m, I plus plus. If taken I, if taken I, then what does I denotes? I denotes level here. So time taken plus equals ti and item taken plus plus simple. and at last time taken plus equals t level, item taken still plus plus. Okay. Now after that, uh, let me write here what after that. Let me mark with something that. Okay. So I'm continuing the code from here. So after that, we simply write what does we are going to write? Okay. So if time taken less than equals to t and end item taken less than equals to s, return 1, else return 0. This is the whole code for the problem. And let's close the function. And the whole code for the problem is just here. So this was without DP. I can write without DP. Okay. Now we will write with DP code. So how we are going to write with DP code? So for that, let me first introduce you to the form 1 of the DP. So before this, it will only take a line or two because form 1 is what we are doing from the beginning. Form 1 take or not take. Whenever we are in a situation that we can take or not take, then we must know that it is a form 1 problem. And how we are going to solve, let me first introduce you to the whole DP now. How we are going to know, how we are going to solve every DP problem, okay? So, let me give you a basic framework. Framework for DP. So, identify the form first. This is the basic. The first thing you are going to do in any DP question is identify the form. That it is of which form from the 5 form I will give. Then decide the states and its meaning. And meaning, what does the state denote? And what are states? States are just the argument that function will take. Like whatever here you are going to give to the function that will denote the states. Okay, and that are states. Okay. So this is states and their meaning. The third step for the DP problem is decide the transition. Decide the transitions. How you are going to move from current level to next level. How we are going to move. Okay. The fourth step is check time complexity. It is a direct formula for time complexity of every DP code. 5 coding part. Okay. So what is the time complexity? So it is a form hashtag states 1 plus hashtag t. Okay. Number of states, number of transition. Like suppose you have taken level, comma, suppose you have taken an array, level, comma, sum of an array. Consider we are going to get much higher argument later in the upcoming lectures. So level, comma, sum. So what is going to be the number of states for this? The maximum size of level that can be, let's suppose it can be n, and the maximum sum that is possible, let's suppose it is s. The maximum sum possible is s. Okay. So number of states is going to be n into s, and transition for form 1 it is always take or not take. So number of transition is 2. So 1 plus 2, and now what it has become 3 and s. 3 is constant, so ignored n into s gives you number of states. Okay, so our time complexity is O, big O of n into s, and that's how we calculate the time complexity, and it is on the steps, and on the steps 1, 2, 3, 4, 5. These are the steps that we are required. So now we have introduced to the form take or not take. Now let's deep dive into the form. So basically it is same for all the code that take or not take. You know what it is. Okay. So let's now deep dive into the DP code of the problem. So coding part for this problem. For this problem, what will be the coding part for by DP approach? Code by DP approach I will write later. So this is the code, and first of all, like always, int recursion, int level, and now we are going to store the sum, item taken and time taken in the function itself. So int item taken, int time taken. Okay. First of all, pruning case, if level greater than n return 0. Pruning case is not always required. We just write it for our own sake. Base case, level equals to n. Return 0, just like the previous non-DP code. There will be a cache check step on, in DP we always do cache check. So I'm going to leave a space for the capsule. And let's move to the main part, that is compute or transition. So int answer equals to rect level plus 1, and we are not going to take the item any, I'm not going to take any item, so lecture. So item taken will be same and time taken will also be same. This is for the which, this is for which part? Not take part, okay? And let's move to the take part. So answer equals but first of all, before taking it, we must know if time taken plus t level less than equals to t and item taken plus 1 less than equals to k, then we are going to take and how answer equals max answer comma rect level plus 1 item taken plus 1 time taken plus t level. Okay, and just return answer. But are you sure that this is a DP code? Until and unless we write the DP array. So simply write int DP. Let's suppose time is this, item is this, time is this, and now just if DP level item taken time taken not equals to -1, return. I'm not willing to write the same code again, so let me see if I can copy this perfectly or not. Yeah, I can, but maybe I need to make it a bit shorter. Yeah, so yes, the code is done, and just one step remaining. Okay, so now this is done, and also we are going to here erase this thing and write again not willing to write just return dp. Equals to answer. Done and dusted. Simply write with dp. So we can see without dp we wrote such a long code with also a good time complexity, but with dp it is of just these much lines. And it is not even hard to understand this code because what we did hard in this, we take or not take, and we just saved our answer and return it every time. Okay, so it is not difficult part. Good problem, I will say. Now let's move to the next topic. So the next problem is also like that. Suppose we have been given a, okay, first of all, change the color of pen, and then let's suppose we have been given an array. X1, X2, X3, X4, X5, X7, X8, X9. Suppose we have been given this, and now suppose we need to that find a subsequence or sub-array that sums up to give a target T. So it is just like an easy version of this problem. This problem was a bit complicated. This was an easy problem for that. So if we know the previous one, we can easily solve this one. Just take or not take any level, not take any level, and move on, move on, move on, move on, move on to the last base case if level equals whatever. Then whatever not equals and then return 0, and you know what to do. So this was the problem. Now let's move to the next problem. Okay, so this how we know to solve. Okay, now let's modify this problem. So the modification will be you have been given q QDs also. Like this will be first array, second array, third array. You need to find answer for all. And let's suppose that whatever you do, the total final number will reach greater than 10 to the power 8. Okay. So if final number is greater than 10 to the power 8, then you know it will never going to become less than, it will never going to be get executed in 1 second. So if it is not going to execute in 1 second, then we need to think upon our thought process. Okay. So how we are going to solve it? Let's see how we are going to solve it. Let's suppose the queries are in 10 to the power 4 range. The sum that we need to make is of 10 to the power 4 and the size of array can be 100. So we know that n into s into q, this will be 10 to the power 10, which is always which is 100 times greater than this, so it will take almost 100 seconds to get executed, and we don't want to do this. So for that reason, this will give TLE. So the problem with this is first how to execute the query part, and second how to print the subset. Till now we know how to get the number, means what will be the size of subset we know, but how to print the subset, these are the two problems with this question, and we need to solve the both problem. It is a very, very important problem. Like you're going to face this problem many times. So one of the best thing to do in these type of problem, in not just because it has queries, but also because that will be the best approach. So what we are going to do is not use the taken variable. Instead, we are going to take left variable. That how much sum is left to be taken. Okay. So we are not going to store the taken. Instead, we are going to store how much we have it is left to be taken. Okay. So our DP array is not going to return that how much we have taken till this level. Instead, our DP array is going to return how much it is left from this level to go till sum s. Like we have currently 15, we want 20, so our DP array will tell that we need 5 more to reach to the sum array. Okay, this is going to be our approach, and then we will take care of printing later because we will create a function to print the subset, and the idea for printing can be used to all problems of these type. Okay, so if it is possible to reach to the so our DP array is only going to return two things, 0 or 1 or true or false, whatever you say, because that is if it is possible to go from this to the sum, then it is going to return 1, and if it is not, then it is going to return 0. Like we have been currently given 15, we want 20, but our array has only 6, 7, 8. So it is not possible to reach 20 because whatever we take, we are not going to get to our sum. So it will going to return 0 in this case. Okay. So, and we are going to use this left thing in every problem from now. That whatever we see, if we need to maintain a sequence or maintain some number that will tell how much we have taken, then instead of taken, we will also always use left. Always. I can write here always. Okay. Remember this. So our DP array will look like level sum left. Okay. Another thing we must remember that the main complexity of the DP array or DP thing is coming from the memset part. Like we do memset to fill the DP array. The main time complexity is coming due to this only. We do this DP minus 1 size of DP. The main time complexity, the hashtag S1 plus hashtag T is this. So if we use it inside the while inside the query, like we have given while q minus minus, and then if we use this inside this while loop for every case or every array, then our while loop will get then our time complexity will also get multiplied by this q. But if anyhow it is possible to use this mem set outside of the QD, then it will be easy for us. And okay, maybe I told something else. The QQDs are given like if we can make the sum, we have been given only one array, and if we can make the Q sum, like we have been given S1, S2, S3, and we need to make these many sums. If we can make these many sums, then we return it for that. If it is possible to make S1, then we return true and print the solution. S2, we will print the solution. S3, we will print the solution. Okay. So this is Q, not different arrays. We will not be given different arrays. We will be only given different sum that if it is possible to make this. So if it by any means we can use the memset outside, because if we have given only one array, so there may be some methods is that we use this outside, and that is where our left thing is going to help, because DP level sum left is always going to be unique. Like from this level, for this sum, only one thing is possible, that how much sum is left. It is unique. Like for the first number, you take, and then if that much sum is possible further, then it will going to return 1, and it is unique. You must understand why it is unique. Let me help you with an example. Suppose we have currently taken 15 and 20 needs to be taken, and in another case we have taken 12 and 20 needs to be completed. So sum left will come as here 5, here 8. Okay. So now DP, and suppose we are at currently n equals to 3. So DP 3, 5, and DP 3, 8. And suppose we have reached to this point before in any QD, it doesn't matter which QD. If we have reached to this point before and we got that we can't make the sum at this point, then it will return 0. And if it is possible to return, if it is possible to make in any QD, if it is possible to make 8, then it is going to return. It doesn't matter which QD, any QD, because array is same. So from that array you need to make 8. If it is possible to make 8 in any QD, then it will going to return 1 or else 0. Okay, got it? So if we are going to use the memset only once, then instead of hashtag s into 1 plus hashtag t into q, it will give hashtag s 1 plus hashtag t plus q, because then the for loop, then the while loop will run. So plus q, and you can see the amount of time complexity change in this from 10 to the power 10 to direct 10 to the power 6. A very large difference from 10 to the power 10 to 10 to the power 6. Like from not possible to possible. Okay. So this is the method that we are going to use. Let's move to the coding part now. we will discuss the approach by code, goes through code. So in coding part, we simply write here, first of all, as always, int recursion. Currently at which level? So int level, int left, then pruning case. And just imagine what can be the pruning case. Yes, it may become int level greater than 1. Yes, it may become level greater than n. So we can write it like if level greater than n or o. Or instead we can write if left less than 0 or level greater than n, because I think this is going to be get executed first. Because left, okay, so why left less than 0 is pruning case? Because left is 0, then it is not possible to take anything from the array now. So obviously it is wrong. So now this is the code return 0. This is pruning case. Now base case. Base case as always, if level equals n plus 1 or n. Here we are doing 1 indexing, so plus 1. I can write due to 1 indexing and not 0 indexing. I showed you 0 indexing in previous cases. Let me show you 1 indexing in this. Okay. Okay, then this is the first. And what if the level is also 0? That level not left. If left equals 0, that is we are currently at a good level and also left is 0. So simply return 1, else return 0. Okay. We can also write if left equals to 0 before this, but I want the code to run till last element of the array. That's why I wrote left equals to 0 inside. Because let's suppose that left is not going to become 0. Then what will happen? At some point it is going to cross the level, and if it crosses the level, then it will be difficult for us to do anything next. Like cloning case will handle it, I know, but yeah, better to write this piece of extra code. Okay, so now let's move further. Then, as always, cache check step. Okay, so now let's first make it smaller. I think due to my handwriting. Okay, so yeah, next. Compute transition. Okay, so compute transition step is going to come now. So int answer equals to 0. If recursion level plus 1 left equals 1, then answer equals to 1. That is, it has returned 1. It is possible at this level to make the sum. It says that it is possible to make the sum at this level. Okay, that's my answer is 1. And simply else if if not by this method and by taking like rect level plus 1 left minus at level equals to 1, then also answer equals to 1. And if by this also it is not possible, then whatever will the answer, we will simply write dp level left answer. Okay, so now and next. Okay, so I have not written the dp thing yet. So in dp level equals 100 and left, suppose left we have 10 to the power 4. Okay, so yes. Now save return. Save and return. So how we are going to save and return? Simply dp level left. You know how to do this. So instead I am going to write the thing in just one line of code. Save and return. So return dp level left equals to answer. Okay, so it has now returned. Now cache check if dp level left not equals to -1. So return as always. Let's use some shortcut. Let's revert. Okay, so yes. Mm. So this is the complete code for this problem. And in the main function, you are going to write memset into main memset dp -1 size of dp q minus. This is going to get executed. Okay, so this is the complete code. Not complete code because we are still left with one problem, that is printing of solution. So next we are going to print the solution. So let's create a function for printing part. So printing. Now what we have our dp array. So can we use, and we also have our recursion function. So can we use our recursion function and the dp array to solve this problem of printing? And if we need to print the solution, so we are simply going to write void print ends, what it is going to take, it the argument will be same as the recursion function. So int level, int left, and just understand these things, that argument same as recursion. Okay, same as rec. Rec I prefer to write then just like that. Base case. Let me first write the code so that you get to see code, and then I will explain the code also. Level equals and plus one, that one indexing, then simply return because it is void, not anything, so we're not going to return anything. Then find the correct transition, that in which transition answer is possible. So if rec level plus one comma left equals one, so call the function again, print ends level plus one left. Now you know why I used the same argument. Else if rec level plus one left minus x level equals one, print answer level plus one left minus x level. Okay. So at this step we took the x level. So what we are going to do? We are going to simply print the x level, because after taking the x level it is going to return 1, that is the answer is possible after taking this. So simply cout x level, and then call the function. Not here, I have just written it, but not here, here. And then simply return. Though you are not, even if you are not going to write this return part, it is anyways going to return. So this is the printing part. I don't think any problem is there in this code, because if the answer is coming from not taking the current thing, then simply move ahead, and if it answer is coming after taking the current thing, then print the current thing and then move ahead. Okay, this is simple, not a tough code. Okay, so this was the complete form 1 thing. After this we are going to study the form 2, form 3, form 4 and form 5. Thank you. Okay, so now what we need to study, this is form 2. So let me write here form 2. So what is form 2? If I ask you a simple question, what is form 2? Uh, I'm left to explain it. So let me explain it directly. Okay. So form 2 is simply longest increasing subsequence. You know what is subsequence? That is for an array. Consider this as an array. So this is the array 3, 2, 5, 4, 4, 4, 4, 7, not. Okay, let's try 4, 4, 7, 6, 8, 9. Okay, so this is the array. Now we need to find the longest increasing subsequence. That is, choose some elements from it such that we get the longest possible increasing array. Okay, so if I choose 2, then I choose 5, then I choose 7, then I choose 8, and then I choose 9. So 5 possible. Then if I choose 2, then 4, then 7, then 8, then 9, then also we have 5. So in any case we have 5. So we are going to write it as 2, 4, 7, 8, 9, or 2, 5, 7, 8, 9. Only maximum 5 sized array are possible. Now, if we need to solve this, can't we think in the direction of form 1? Like, what does form 1 state? Says that we can either choose it or leave it. So in this case also, either we can choose this element or leave this element, choose this element and leave this element, and do our optimization to get the maximum longest increasing subsequence. So it is possible. I am telling you, it is possible. Okay, it is possible to do that. So why not first solve with the form 1 only? So if I go with this, let me first take it here, take it here, delete this, make it a bit small. Okay, so yeah, and also let me okay, so let me simply I'm going to decrease the size of this also. Yeah, so this is the whole thing. Now let's start with form 1. Because we can. If we think we can, then we can. Obviously, the first thing is LCCM. So level, current element, choice, take, not take, check. If current element greater than previous element. Okay, and move. That is takes less not take. Okay, so this is our LCCM. Now let's think about the state. What can be the state? If we want the current element to be greater than previous element, then we need to store the previous element somewhere. So why not we write it as state dp level, comma, or I can write here direct level, comma, previous element. Okay, this is the thing. Now transition we know from the check. Let's directly do TC check, time complexity check. So by this, hashtag number of states equals previous element. So I can write max ARRI, max element of add. Okay, this is the time complexity for this code. Then now, what is number of what are the number of transition take or not take? So only two transitions. So we got final complexity as O and max ARRI. This is the final time complexity. So the form one type code will be, I will show you in just a minute. But before that, let me also tell you that instead of directly using the element, we can also use here index of element, so that it will become O(n) into n, because the maximum index can be n minus 1, though I have written n. So O(n) squared will be the time complexity. Let me write here so that you don't get confused. If we use index instead of element. Okay, so this is the case. So now let me show you the code. I have already written the code. So this is the problem. Longest increasing subsequence. Given an array nums, return the longest. And this is one of the example. And this is here the code. First of all, we created the DP array. And see, here we have a new type of thing that we can, instead of directly using d if dp equals to -1, because here element can be -1 also. So we simply did a check dp. Okay, that is if dp is equals to -1, that is if check dp equals to false, then we are not going to return this, and if check dp is true, then it is going to return the dp at that point. So if level equals greater than, okay, this is pruning case, and if we write in two types, that is pruning case, then base case, then greater than n and equals to n array will come. Okay, so int answer equals to this. If previous element, that is the first, for the first element, it will always going to take it and increase it. Okay, so this is the case. This is a must thing that we must write. If previous index equals -1, by which we have initiated the thing, that is we sent here -1, so there is no index -1 and array with, and the nums array is going to access that nums -1. It will give a runtime error. Okay, simple. That is, if we don't write this thing here, then it will going to return -1. Then it is going to return the error, because it will first check num's previous index. Here it is going to access the nums -1, and it will automatically give runtime error in every case. Then it will give runtime error in this. That's okay. So this is the case, and you can see the code is easy. It is not so difficult. One square code, but you can see here that it is not so much efficient. Still, it is not so much efficient. We can see the time complexity is O(n) squared here. So is it really helpful, this O(n) squared time complexity? No. So what we are going to do, we will optimize this, but we will study the optimization later. That is, here we can see that we can make this code in O(n) log n time complexity. This is a follow-up question. It is possible to make this in O(n) log n by using the binary search method, but we are going to study that later. First of all, now focus on form 2. We have studied how to solve the problem using form 1. Now let's study it with form 2. So what is form 2? What is form 2? It is like, suppose we have been given multiple elements, then dp index or configuration, comma something. What is this something? If you ask, this is the best ending at that index. What does it mean here? Like, if I ask you, or let's suppose, let's copy the previous array. If we copy this up, so if we copy this up, then if we apply the form 2, then what will be the best longest increasing subsequence at this index? For index 0, what is the best LIS? So you will say 1. For 2, it is still 1. For 5, it is 2. For 4, best. I am asking the best. So 2. Again for 4, it's 2. For 7, it's 3. For 6, it's 3. That is 2, 4, 6. For 8, it is 4. For 9, it is 5. So the best LIS is going to be this 5. This is easy to understand that the best ending at that index is going to get stored in this LIS. Now what will be the state for this problem according to form 2? So if we write dp here never, comma, so do we really need another thing? Because we can write the best LIS ending at this index in the array itself. So if we create another array, then for each level we are going to store the best LIS, that is 1, 1, 2, 2. For each level we are going to write this, then there is no use of using another argument. Okay, so we are not going to use the another argument, and we are simply dp level. Okay, this is the thing we are going to do, dp level. Then simply move further. I think I should write here reason also why we are not. No parameter here because we simply write LIS for each level. We simply write LIS for each level, therefore it is not required. Now let's discuss some other thing, that is transition. We have now got the states. Now let's discuss transition. So what will be the transition? Transition. So what we wrote here, that for each level we want the maximum LIS, that is maximum of the DP of previous taken, and we will add 1 to it. So maximum DP previous level plus 1. Okay, and the previous level should be less than level, and also the number that is here nums previous taken must be less than nums level. Okay, so this is the code. This is not the code, this is a transition. We can also check the time complexity here. So how we are going to do the TC check? How transition is done, because we are going to move through all the elements. And how states is done, because there is only level. Okay, so this is the thing. Again, our time complexity will come as n squared, just like form 1. Now let's move to the coding part. How we are going to code the form 2. First of all, just like every question, int recursion level cloning case. What will the cloning case? If level less than 0, return 0. And what will the base case? If level equals to 0, return 1, because 0 is possible element. Now obviously, as always, case check, but we are going to do it later. First of all, if answer is correct without case check or not, let's check. Compute slash transition. So as always, int answer equals to 1. So for loop is become plus plus, just like how the for loop works. Now the main thing, if here pre taken less than level, we are going to check for all the previous element. That is for all the previous element. If anytime previous taken is less than level, then we are simply going for int answer equals to max answer 1 plus recursion of ARR level. Not ARR level, only level, okay? Because we are passing index here. back level and just close the thing, save and return how you know we do it. Exactly the same way we did it till now. Okay, so this is the complete code. Just one thing left. Into DB level if DB level this is the whole code. Now we can simply write this code in the same way that we wrote the form 1 code. Okay, this was the complete code, and now let's try to implement this in the problem. Okay, so let's move to the problem. This is the problem, and this is the code we used to solve it with form 1. Okay, so now let's do some changes and make it the form 2. So the changes goes like, first of all, remove wait a second, let me see the code what it says. So it goes like int db rate level less than 0, this is gas check db level इतना compute transaction if previous taken. Okay. No need to say the previous index. Num size. Okay. No need of this. Never required in this because the state is only never. Okay. So no need of this. Of this. This. Okay, answer equals to 1. First of all. Now remove this complete thing. And then check. We need to call the person. This should work according to our code. Okay, okay. I understand. Okay, so this is giving output only as one. Check what the error is. So now we will be solving another problem, which is max sum path. So what does this problem states? It states that we have been given a box, a 2D array. Let me draw the 2D array first. So this is our 2D array. Let's suppose we have been given many numbers, and our target is to go from here to here in with such a path that we get maximum sum along it, and we can only move right and down. That is only this allowed. Okay, only these two ways to move are allowed. So we need to find the maximum sum from this to this. We can move like this, or this, or this, whatever. Everything is possible. Okay. So how we are going to approach? First of all, step one, choose the form. So what does the form says? Take or not take. Can this be solved by take or not take? Like I moved here, I have option either to take it or leave it. Move here, either to take it, leave it. Then move ahead, take it or leave it, take it or leave it, take it or leave it. Two options in these two. Everywhere I go, I have only two options. Okay, just these or this. The best sum can be in between these. This is one of the method. It can be solved using form 1. Now, can it be solved with form 2? What does form 2 says? best till current. Like suppose I move here. Now what is the best till here? This. I move here. Then what is the best till now? Best sum till now. This, whatever. Many options are possible from here to here. Just like this, what is the best from here till here? I need to find. So yes, this can be solved with form 2 also. Okay. So how to solve this with form 2? First of all, let's decide the state. Step 2 was to decide the state. So what will be the state for this? So the state for this can be row, comma, column only. Just like in previous question, we have the state with level only. Just same here, we have row, comma, column only. Okay. And what are the methods to move? If we move from here to here, let's take row as maximum number and column as maximum number. And then instead of moving from 0, 0 to m, n, I will move from m, n to 0, 0. Both are same. But I told you that how much left is easy than how much I took. I told you this before. Okay. So instead of going like this, I will go like this. Not? Yes. Okay. So this will be our approach. This will be max. So if we move from left to right, that is here, then our row is going to get subtracted by 1, or I can say dpr minus 1 comma c plus arr rc. Okay. And if we move down, then simply dpr c minus 1 plus arr taking current. Okay. So this will be our transition. We have decided the state. Now we have decided the transition too. So this is our transition. Okay. Now let's discuss time complexity. So time complexity is also not so difficult because we have only two transition and state is 2, that is m star n and 2. State transition, and mixing both we get O m into n. Okay. So this is our time complexity. Now the only thing left is code. So let's discuss the code part 2. So what is the coding part? If we discuss, so we get like int bp as always, creating the dp array first, which will be used in the cache check function. Then simply writing this also, just like we did in previous question. You know why I'm using this, okay? Then writing the function int add int c. First of all, pruning case. So what will be our pruning case? If r less than 0 or c less than 0, then return okay. So now I'm leaving this part for now. We'll talk about this later. That what we are going to return. And base case will be if r equals 0 or c equals 0, return again something. Or this is not so complicated because when this is 0, then we are at this point, and at this point we must take it. Okay. Now cache check, simply if done r c equals true, then return tp r c. Okay, so this is also done. Then comes the main part. Computing slash transition. Okay, this is the main thing. Now first of all, int answer equals to, what will be the answer? What do you think? We need maximum. We need the sum maximum. So we can, we need answer to be minimum such that we can compare it if the next thing is maximum or not. So we are going to say this will be int min. Okay. Now what will be the answer? If r not equals to 0, though we have checked it before also, so we don't need to check it again. So I can directly write it as answer equals to max answer comma rec r minus 1 comma c plus arr or not, yes, arr r comma c. Okay, and answer will be max answer comma recursion r comma c minus 1 plus arr r comma c. Okay. Another way to write this as answer equals to max copy this and copy this. Okay, so I can write these two same as this. Okay, now we'll simply say save and return. So return, first of all I should write it as and then so this is the whole code, but still we are left with this. So what I am going to put in that? So if we observe carefully that when we go r less than c and c less than 0, which is obviously not going to be happen because of the base case. But let's suppose if it goes, then what I mean by this is we have come here or here, I don't know. Okay, we have come here or here, which is still not available. So should we really return 0 here? Like really 0? If we return 0, let's suppose, then here we will get r plus r comma c 0. Okay, and if it gets 0, then it may be possible that this answer get used. Okay, this answer may become maximum, but it is not possible because by then this answer, one of the answer will get chosen and this will get rejected. So this is not going to happen. So instead of that, what I mean to say, or exactly not here and here, but anywhere, like here also, here also, here also, here also, here also, here also, here, anywhere it can go, okay? And it may accept that answer 0. And it's not perfect because after this 0, it is not going to further explore this path. But we need path from here to here and not here from here. So I want to completely reject this path. I should mark it with red. That I want to completely reject this path, completely reject this path, completely reject this path, or completely reject this path, completely reject this path, completely reject this path. How to completely reject the path? So to completely reject the path, I must write here int min. So that int min, if gets added here, if added here int min, then this will automatically become minimum and it will always return the answer and not this. Similarly here, okay, that's why I will write here int min. This is an important thing. So this is a question. This is just a variation of the question I told you. In my question, you need to find the maximum sum path, and in this question, you need to find minimum sum path. So let's just write the code the same way we wrote it here. There, so first of all, Dhoni, if r less than 0 or c less than 0, return int min. Max actually, okay, here int max because we need to find the minimum. Then the base case, if r equals to 0 or c equals to 0, not or actually, and okay, if this happens, then return grade 0 0, okay, and also let me pass this, okay. So this is now int else equals to int max else equals to min rect minus 1 comma c comma grid, thus grid r c r c minus 1 grid, okay. You can write this or you can write this actually, because m cross n I have been given, but I have not been given the uh, first of all, let me write here int m comma n and then write here m equals to grid dot size n equals to grid 0 dot size, okay. This is the thing, and then I can write it as return rec m comma n comma grid, okay. So this I will return will be minimum this, okay, this, that's this, and then finally return answer. So this is the whole code. Obviously without DP now, but let's just check if our answer is correct. What is the integer overflow? Hmm, in this I got integer overflow. But why is this? Let me check. Okay, so my error was uh, when I was using int, then what was happening that int max plus int max is getting returned sometimes, and int max plus int max is obviously not handled by the int integer. So I wrote now it can handle even two int max. So maybe this should give the correct answer now. Let me try to submit it. Uh, okay, so before submitting, let me also use the DP. So DP, what are the constraints? 200, 200. Uh, okay, so base case, then I will write gas check. Is negative number also possible? No. So if let me write the map set dp comma -1 comma size of dp if dp are c not equals to -1, return dp are c. Okay. Always remember that if the element can be negative also, then we will use the done. Like here I have wrote would done. If the constraints are negative, then I must write done also. But here it is not negative, so I will simply write this. Let me try to run it again. Gas check done. No error. Let me try to submit it. Hopefully it passes on the okay. Got really okay. Yes. DPR C equals answer remaining. Now I try to submit it. Hopefully it passes on the test cases. Yes, it passes and beats 61%. If you will analyze the time complexity, it should come as ON squared. Let's analyze the complexity. OM into N, obviously, as I said. Perfectly fine. Accepted. Okay, so this question is done. Okay, so the form 2 is now completed with our two examples. Let's move to the third form, that is form. Let me change this. Form 3. So, what is form 3? The best example for form 3 is LCS, which is also known as longest common subsequence. So basically, form 3 is we have been given multiple arrays. I am not saying two arrays because there can be more than two arrays. So we have been given multiple arrays, suppose, and what we want, first of all, let me, okay, so now, Create an array and let me delete this first. Simply copy this. What the? Okay, wait a second. What is happening? Okay, so first of all, let me this and then copy. Okay, so yeah, so we have been given multiple. In this example, we are going to take two, but we also we will also show you how to do it for three. So suppose there is given like A, B, C, E, D, G, H, U, F, and C, X, D, O, M, P, U, D, C, not C, G. Okay. So I want longest common subsequence. So first common is this and this, then this and then this and this. Okay, so only three common, I can say. Basically, if we have been asked what is common completely, then I may write F, G and G as here, but then it will not be in sequence. Okay. Don't need to change the relative orders of the elements. This is longest common subsequence. Form 3 is basically this. There are many problems that can be derived from this single problem. Okay. Me change the color from a bit deeper. So yeah, this is basically thing. So then let's discuss how to do this. So how we can do this if we think. Suppose what we can do, the first element will match here. No, it is not matching. Then it goes here, 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 here. It does not matches anything. Second, here, 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 here. It does not matches. Then third here, it matches the first element. Then fourth, either AI will equals. Let me write the thing here. AI is equals BJ, where we are pointing currently, or AI equals BJ plus something, or AI plus something equals BJ, or AI plus something equals BJ plus something. Only these are the four possible cases. That is, either it will match if we are currently pointing here and here, then it will match the first, or this will match something ahead of this. or this will match something ahead of this, or these both will not match and something ahead of both will gonna match each other. Okay, so these are the all four cases possible. So now these are how the match is gonna happen. We can solve this with form 3 also. By the way, it is also known as multi-sequence DP. What is its other name? Multi-sequence DP. Okay, multi-sequence DP is just that its other name, what people call it generally, this form of DP. So we can solve this with form 2 also. How we are going to solve this with form 2 also? Suppose dp I comma j comma something other state. This will be best count of longest common subsequence in first array and second array. Okay, best count of this, best count of longest common subsequence. If we think upon it, we may solve it with this method also. But now I will show you easier method with this time complexity in this. Because if you think, then it will become something like m into n into something. Okay. So this is already very big large number. So we are going to solve it with this method, and how this method is working. Let's see. First of all, make it smaller. Let me write it here, making it even smaller. This will be just here, making this smaller. No, not the case, I think. Yeah, so this is the thing. Okay, 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 okay. Let's see now if I can make this not this. Some three remaining. So yeah. Now I can make it small. Though I don't need to make it smaller, I am trying to fit the approach in one page so that you can see it in just one place whenever you want. Okay, so this is the whole thing. Let me create some more space by writing it over here. I don't know what. Okay, answer is 3. Let me write the answer here. Okay, so now we are left with a good amount of space. Now let me solve it. So the first thing is choose the form. When I told you that it is form 3, then we already chose the form. We have studied what is form 3. Second step will be create the state. So what will be the state? If I am just cared about I and j and something will be cared in ij, then I can write a state as simply dp I comma j. Okay. Now transition. We can see 4 steps are present here. So there will be 4 transition, but let me show you there is a catch in 4 transition. So instead of writing it like this, let me write it like this. Okay. So yeah, it will be simply dp I comma j plus 1. Second will be dp I plus 1 comma j, and third will be if ai matches bj, then dp I plus 1 comma j plus 1. Simply we know, we can understand why. And if you think that why we are not taking this fourth case, that is when both are not same, that is it will not match this or this or that. Then in recursion we know that everything is get counted. If I am writing one I plus 1 here, and in the same code I am writing j plus 1, then it will happen that it will get called, and in that recursive code it will get called, and this I plus 1 I plus 1 1 1 1 1 1 going to increase in both if the condition is not fulfilled. Okay, so basically this is doing the same thing that I said, that first it will going to check this, then second it will going to check this, then third it will going to check this, then fourth it will going to check this. But as we are using the dp, so dp decreases the time complexity very much. Okay, so this is the whole code, not code, but this is the whole framework how the code is going to happen. And then what we are going to do, finally we are going to take the max out of it. How we are going to take the max out of it? By simply using max function. Max out of it. Okay, because we have been, let me make you understand the question better, because we have been asked to only find the length of the LCS, but we can print it too. Okay, we can print it too using the printing method that we have already seen before. You remember that? The printing method is the only and the best method for printing. We don't need anything extra more than that, okay, in any DP code. So we may now proceed to write the code, and the code is very small here. Let me simply write the code. First of all, int dp. Let's suppose constraint have been given like this. Okay. Then simply int recursion, int I, int j. Okay. As always, pruning case. If I greater than equals to m, or j greater than equals to m, return 0. We have take care of the base case also in this prowling case, so we don't need to write the base case separately. Simply doing case check, that is if dpij not equals to -1, return this thing. Okay. Now computing or transition. Okay. So int answer equals to 0, answer equals to max. Now writing the whole three things that we have seen. Answer comma rec I j plus 1 and if we know why we are writing 1, because we simply need length of the subsequence, longest common subsequence. Okay, so this is the whole code. Then simply save and return, that is okay. So as I already said that it is a small code, and for three arrays, if you need to find simply write I comma j comma k and extend this. What do you mean by extending? Like you have to written here I comma j plus 1, I plus 1 comma j. Simply write here max answer comma I comma j comma k plus 1. That will be the third variable. Okay. So this is the whole code. Let me code on the neat code now. So we are on the neat code. Let's code this first. So first of all, int dp, what is the maximum limit? Now direct. First of all, clone case. M comma n m equals to text 1 dot size m equals to text 2 dot size. Okay. And we should also copy this up, print this up, and not in form of text 1 but comma b. Okay, so simply write here if I can do it like this also. One, two. So now if I greater than equals to m, j greater than equals to n, return 0, else check if dpi j not equals to -1. Yeah, also this that mem set dp -1 size of dp. So return dpi and j. Okay. Now simply compute transition in tensor equals 0 equals to -1 and I equals 1 comma j comma j plus 1 equals b. Okay. So now then what left save and return dpi answer. Okay. Just calling function def return 0 comma 0. Hope this runs successfully, and yes, it is complete. Let me see, nothing should be left. Okay, simply okay, not. So yeah, let me run again to show you that it is correct, and now simply submit it. It is submitted successfully, beating. Okay, I know. So yeah, memory is better than 80% obviously. So you know the whole thing now. This is the whole code now. And we have also studied that there is nothing much in form 3. Now let's simply move ahead to our next form, that is form 4. So what is form 4? Simply we call it NRDP, which also means left right DP. So what does left right DP means? There is one famous problem for it, which is also called rod cutting problem. What does this left right means? Suppose we have been given a rod. Okay, rod. Okay, so this is our rod. Now let's suppose we need to find the best way to cut the rod such that, let me try to show you the problem if we get it. I haven't got the formal problem, but let me explain you what the problem is. Okay, so we have been given the rod, suppose this rod, there is end 0 and let's suppose there is end n. Now we have to cut the rod such as, cut the rod into and different, see that this is and this n and this n is different, this is capital and this is small and denoting different things. Okay, and different parts such that it has minimum cost. Now how we are calculating the cost? So cost equals size of rod being cut. Okay, so if I need to cut this rod into 3 pieces. Okay, so suppose I have to cut this rod into 3 pieces. How I am gonna cut? Let's suppose first I cut at 2, length 2. So I have cut the rod into n minus 0. I have cut the length. What was the initial length of rod? N minus 0. Okay, so when I cut it at 2, the price was n minus 0. Then I cut it at, let's suppose 3. Then the price will get added to it, that is n minus 2. Okay, and the whole price is going to get added, that is 2n minus 2 is whole price. Now we need to minimize this one, this price. What is the alternative method to cut it? Suppose I cut it like, let me first copy the whole rod from here. Okay, and instead of this, okay, so now I cut this rod into here n by 2 and not even n by 2, just 2. Okay, and then here 1. So I cut this one first and this one second. Okay, it got cut into 3 parts. I have only been asked to cut into 3 parts, not perfect, not any length. Okay, so now what I have done, that first n minus 0, and what I have then added 2 minus 0. So this thing becomes n plus 2. Instead of 2n minus 2, it has now become n plus 2, which is very much lower than this. So this will be accepted and this will get rejected. Okay, so this is the whole problem. Hope you have understood the problem, how we are going to find the cost and how we are going to proceed this problem. So this is the NRDP, and why it is NRDP? Because this is L, this is R. Here this is L, this is R. Now you will understand how this is LR and how the name LRDP came. It is also called interval DP, just like previous problem was called multi-sequence DP. It is also called interval DP because we are cutting at interval. Okay, so this is interval DP. Now when we know this thing, how we are going to proceed it. So first of all, let's discuss the state. We know the form now. Second part is state. So state is simply dp comma r, which is denoting, first of all, let me write state here so that you don't get confused. Let me write it state, which is denoting best way to cut xl xr. Okay, so this is the best way to cut. How it is get calculated? Like this, xr minus xl thus dp l comma p. Okay, so I will explain you how this and what this p is later. Thus dp p comma l p comma r. And if you think upon what I have written here, then you may guess what I'm going to proceed. Okay, and if you still can't guess, don't take any stress. Anyways, I'm going to explain it. Okay, so we have to find the minimum of this for all p. Now you know why I have written that. Okay, so this is the whole thing, minimum for all. Okay, so now once we have decided the state, now we need to find the transition. So what is going to transition? We are going to call this thing p times. So simply, and p is from n to r, that is 0 to n. So transition is going to happen from 1 plus transition going to happen 1 plus n, not 1 plus n times. Transition is going to happen n times because we are calling this function n times. So transition is n times. Now we have discussed the transition, we have discussed the state. State is n into n. So time complexity is going to be O n into 1 plus n, which is O n cube. You may think that this is a very large time complexity, but with the difficulty of this problem, we have been given an small value, okay, like 100. So if you still calculate it, we're going to get 100 into 100 into 100. Six times 10 to the power 6, and it is still less than 10 to the power 8. So it will get calculated in 1 second only. So yeah, this is fine. Now we simply need to write the code. You have understood the problem, you have understood the state, transition and time complexity. Now only solving the problem is left. So we can write the coding part now. Coding part goes like first of all, as always, P. Let's suppose I write 101, 101. Okay. Now int recursion, int L, int R. Okay. So now, as always, pruning case, which is if L greater than equals to, or I should write much better as L plus 1 equals to R. We use this in binary search algorithm, if you remember. This thing, not exactly, but this thing, okay? Return 0. Then comes the cache check thing, okay? So cache check if dp not equals to -1, return this. This is the cache check that we are performing. Then comes compute transitions. So int answer equals to 0. Now for int I equals to L, I less than R, I plus this. So what I wrote in the previous page, answer will be minimum of this. Answer equals minimum answer comma xr minus xl, or I should write ar minus al. How I wrote, I just want to write the same way. Okay, so this rec l comma I plus rec I comma l. Okay, so this is the same way. And now simply save and return. This when I iterate over on this, I said for all and minimum, for all and minimum. Return dp and r equals answer. Okay, so this is the whole code. I didn't got the problem, but this is a very famous problem. You may find it on any website like Geeks for Geeks. On LeetCode, it is a bit different. Like if I want to explain, I can explain that in the Geeks for Geeks, it has been written that I have been given the rod, I have been given an array. Okay. So the array consists of numbers where I made the cut. Now you need to find the minimum of how the process should go such that it get minimum. So it is a bit modified, but yes, it's still the same thing gonna use in it. Okay. So this is a famous LRDP. You may use it in any case where you need to iterate over all the cases from left to right, like in an interval. It simply remember interval DP. Whenever you need to find something in an interval, you are going to use it. So I can write whenever you need to find something in an interval L, R, use this form 4. Okay, so you may remember it like this. So now form 4 is also over. We are left with only one form, which is form 5, and form 5 is nothing but game DP. So game DP is what first person chooses one stone, second person chooses another stone, such as, and this game continues such that no stones are left, and the person who can't choose any stone now is going to lose. This is the most common pattern of this problem. So yeah, it proceeds it like this only. At last, sometimes a pattern comes. You just need to observe that pattern. Then you can write a very basic code on that pattern, based on that pattern. Okay, like 1 0 0 1 0 0 1. This type like pattern comes. So you may code it like that only. But yes, first you need to identify the pattern using the game DP thing. So game DP is a whole different thing. It is not a pattern based, but yeah, you may write state, transition, and all thing. Okay, that the 4 steps I told you, you need to remember that in all DP problems. All problems will come from these 5 forms only. Okay, so just remember it, and it is more than enough. Now, what we will study next? Not now, but what we are going to study next? Next will be how to solve the NIS problem in n log n using binary search. Okay, so next will be the problems, and this is one. Then it will be subsequence, the substring, state ideas. Okay, this is the next. Then we will also study a thing called bottom up DP, also known as iterative DP. Now, till now we have studied recursive DP. Now we will study iterative DP. And after iterative DP, the thing will get over. Then you can also study the cadence algorithm, which is one of the most revolutionary algorithm, I would say. It is a form of DP, but yes, one of the most revolutionary algorithm, I would say, because it transforms the string problem from on square to on. If you use Instagram, then you also may have seen this meme. Then there are some ICPC level problems like ICPC level problems. I'm not going to discuss in class, but after reaching a certain level, you may proceed to solve those problems and understand those problems. Okay, so one of the problems is polygon triangulation, though I am not going to solve it in the class. You may search it and try to understand it. So we will study everything except this. Okay, these 4 topics are left. Cadence algorithm also I am not going to teach. So okay, these 2 things I am not going to teach. These are other topics, but yeah. I will teach you these three topics, and game DP is easy. You just need to find the pattern. Okay. So we may now over this class. Thank you.